Hi, teacher.
Hey, Robel, how are you?
Good, good.
I got you down as here. All right, get your paper. We're taking notes.
No problem.
All right, now, good news is this is our last new lesson. Billy's here. This is our last new lesson for the unit. So we're gonna do this lesson today. I want to hopefully be done like 11:30, 11:40, so we have 20 minutes to work on the homework together. Um, just a quick reminder that if you are coming to class, that's awesome. I want you here with me. I want you with the group working on math. But you're not going to get credit for the class if you're not doing the homework assignments. So here's what we have so far: mastery tests. Basically, it's all the mastery tests in the unit one. And then today we'll be adding on the final mastery test. It's the last one, solving linear inequalities. So these are all the names, but frankly, it's just all of the mastery tests. So we've done all of them: expressions, linear equations, solving linear equations, solving advanced linear equations, and then yesterday was literal equations. These are the ones with lots of variables in it, and we're solving for just one of them. So tomorrow we're going to do an online worksheet together. That's Wednesday. Thursday, I guess we'll do a review together. And then Monday, we're going to take our test on Unit 1. That's our short term plan. Any questions or concerns at all about that schedule? Please.
Josiah,
Tira.
did we already do solving advanced linear equations and solving literal equations?
Yesterday was literal equations. That was what? Monday the 20th? Video's up for that. And then
Okay,
I think this other one, advanced, was Thursday.
okay,
I can't remember the date right now. It was 15th, maybe 9/15. So, excuse me. So on the video page, you should see the dates there, the date I uploaded, and the date is in the title, I think. I've been meaning to put the dates in the title. So that hopefully will help find it if you need that.
okay, cool.
This one was Monday 9/20. And that one's there for sure. Advanced linear equations should be. I'll double check everything afterwards, but I'm pretty sure we've got all our videos up, and the dates are visible. If anyone knows how to use YouTube maybe a little more better than me, what I'd like to do is separate Math 1 and Math 2. So that might make it a little easier for you guys to find what you need, especially as we continue. Like when we get to Unit 3 and 4 and 5, there'll be like a million videos there and harder to like dig through and find. So if you know how to separate that out and you want to don't mind helping me with it, maybe you could tell me about that later. I appreciate that. Any other questions, please? Let's jump in. Solving linear inequalities. Linear inequalities. So instead of an equation, we're dealing with an inequality. Let's talk about what the difference is. Here we go. So, what is an inequality? Basically, it describes how two things are not equal to each other. That's hinted at in the name, right? Inequality. We know what that means. We know that it's in society, it's when there's an imbalance and two different types of people usually are not treated equally. The same thing is true in math. So an inequality means we're explicitly saying instead of these two items being equal, like in an equation versus inequality here. In an equation example, we have x equals 5. And we're basically stating this variable x has a value or an identity of 5. It's equal to it. Pretty straightforward. For an inequality, here's an example: x is greater than 5. Let me back up, sorry. x is greater than 5. I'll write that down here. That's how we say that. Notice that there's no equal sign, right? It's just that other little symbol. And how we read it, what that means is x is bigger, x is greater than 5. So we're explicitly saying x is not equal. It means it's bigger than 5. And this is just one example of an inequality in math. Also write this down. Equations have only one solution. So there's only one number I could plug in here for x on the left equation, this one. It has to be 5. That's the only way to make this true. However, inequalities have an infinite number of solutions, meaning there's like a whole bunch of different numbers that we could plug in for x here and make it true. For instance, here's a couple extra examples, like 6 is greater than 5. That's true. And 20 is greater than 5. That's true. And, 1,000. And there's so many more. I'm just kind of randomly picking a few. These are all true. But there's 3 different values for x that we substituted in, and they're all true. So when we're dealing with inequalities, there's an infinite number of solutions. Basically, infinite means it goes on forever. There's no limit to the number of solutions for x. It's all numbers that are bigger than 5. Any questions so far? Concerns, please. Okay, so let's look at the 4 different inequalities, because we're not just dealing with greater than like we saw recently. We're dealing with 4 different ones. So I have this laid out as like 4 rows kind of. So I want to show you how we write it with math symbols, how we say it, spoken, written, and then how we're going to graph it too. We can always graph our answers, our solutions for inequality problems. So here's our first example. Let me let in this student. Here we go. Okay, good morning to the folks who just joined. We are doing inequalities. And you did miss the first like 2 slides. So later you might want to check out the video if you have any questions. Okay, so here we go. The 4 inequalities with examples. So I'm presenting them kind of as examples, actually. Our first one is in math symbols, and we just did this on the other slide, was x greater than 5. And how we write it and say it out loud is x is greater than 5. How do we graph this? So you would scroll out a number line. I have these already pre-made, but in general, what I like to do is whatever the number in question is, in this case, it's 5, right? It's comparing x to 5. I would make a number line with 5 kind of in the middle. I'm going to circle that number, 5. And then I want to show all the numbers bigger, greater than 5. So I'm going to like color in or shade or cover all the numbers that are bigger than 5. And to symbolize that this goes on forever, I'm going to put an arrow on the end, meaning it goes on forever. Like it's not just 10, right? It's not just 6, 7, 8, 9, and 10. It's all the numbers bigger than 10 too. Okay, any questions, please, before we move on? Okay, so kind of the reverse of the first one is x is less than 5. X is less than 5. The procedure for graphing it is the same way we did the last one. So you're going to make a number line, a straight line, put 5 in the middle, we circle 5 to indicate that we're like focused on it. It's our number in question here. And then, but this time we want to cover up all the numbers smaller, less than 5. So 4, 3, 2, 1, and everything lower than that as well. And throw an arrow on there to signify that it goes on forever. Okay, now there's 2 more versions of our inequalities. Here's another one. X is greater than or equal to 5. So notice the difference. Equal to gets that little bar at the bottom with our math symbol. That's kind of like half of an equation, of an equal sign. It's like the bottom bar for the equal sign. So when you see that, it means greater than, because it's the open side first, and it has the equal bar underneath. So it's both. So this technically is an equation, but it's also an inequality because greater than is included. So still we find our 5, our number in question. We want to shade above, so greater. So it looks just like the first example. But because it has equality, okay, because of this equals, because of that little equal bar, we're going to fill in our circle. And this signifies that we are including the 5. 5 is included in our solution. Fill in your circle. 5 is included. It wasn't included before because 5 is not greater than itself, right? Like our first one at the top. But for greater than or equal to, it is equal to itself. So we get to include that number in the solution. And so you can probably see where the last one is going. X is less than or equal to 5. So you find your 5. We're going to fill it in because it has that equals portion attached. And then we're going to shade lower because it's less than. Any questions right now about these 4 signs or any of the work we did?
None for me.
Thanks, Levi. Let's see thumbs. I'm going to come back. You know what? I'll wait a second if people are still copying down. And then to get ready, I want your cameras on. I want to see your thumbs, how you're feeling about this so far, these definitions. Really, we're just kind of defining stuff so far. So give me 10 seconds for people to copy down, and then let's see thumbs. I want to see how you're feeling. Thumbs up, pretty good. Thumbs sideways, I'm doing okay. Thumbs down, I'm not doing okay. Or how else can we say that? Thumbs down is like, I need more practice with this. I need more time with this before I try to explain it to someone later on my own. All right, I'm going to check out the camera here. Just want to see some quick feedback from you guys. Okay, I see Savannah. Thank you, Savannah. And Levi, thank you. Lauren, I see that. And Maria, thank you both. Anthony Torres, thank you, sir. And Tira, thank you. I'm glad people are feeling pretty good about this so far. How is everyone else doing? If you haven't shared yet, can I see your thumb, please? Or type it in the chat, I guess. But I need some feedback from you folks. How are you doing with this topic so far? Okay. Well, I hope you're doing okay. Maybe I should take that as a sign that we're not. Let's get back to it. All right. So a quick word on how to read the inequality sign. Because I've noticed that there's often some confusion about is it less than or greater than, right? Like, how do we know which one it is? So here's another example. X And notice that the symbol, right, is pointy side first. Pointy side. And then we've got our open side. That's how I like identify it. So I see the pointy edge and the open side of this symbol. So basically, and this one is red, x is less than 8. X is less than 8, and it hits the pointy side first. The pointy side stands for like the less than side. And the open side is the greater than side. So really, folks, this symbol is both. It is basically less than and greater than. How we know which one to read it as greater than side. How we know which one to read it as is basically how our like statement is arranged. So x less than 8. Well, which side do I get to first when I read that? I'm reading from left to right, of course. So x, then I get to my pointy side, so that's less than whatever the number is, 8. Now, another side example, let's say we had x and then this symbol and 10. So this is read x is greater than 10 because we get to our open side first when we're reading it. So x is greater than 10. So how we know which sign we're dealing with is basically which side is like close to the x or to the variable. You could also read inequalities backwards, and this can get confusing, but it means the same thing. So looking again at our first example here, x less than 8. So to read it backwards, I would read it from right to left. 8 is greater than x. And either way you read it, it is telling you the same information. So I like to read left to right. I try to keep it that way always. But sometimes we'll have problems where the variable's on the other side. In which case, you can read it from right to left, but then I would read it backwards as well. So I would read this one as 8 greater than x, or you could read it as x is less than 8. And both versions are true. Legitimate. Any questions on this? Comments, concerns?
I'm good.
Okay, thank you for the feedback. Was that Tira?
Yes.
Okay, thought I just recognized your voice. All right, I hope everyone else is feeling okay. Just remember, read it from left to right like we usually do, even in math, and then whichever side you get to first, that's the symbol we're using. So pointy side first is less than. Open side first is greater than. Let's try some problems with these symbols now. So I didn't write this down, but I'm going to put it at the top as a note. I'll say this. To solve inequalities, treat it like an equation. So what do I mean by that? Treat it like an equation. Basically, follow the same rules and procedures we've been using for all our other equations we've been solving this last week and a half, 2 weeks. So identify what's happening to the variable, do the opposite to both sides until it's all done, until the variable is completely alone. So I want to get my f here all alone, isolated. So what's happening to it? Well, it's being added to negative 12. So it's being added. So that means how we're going to combat that is more adding or subtracting. Now, technically, I'd want to subtract the negative 12 from this. But subtracting a negative sounds like a lot of extra minus signs. We can also add the opposite of negative 12 here. So if I add a positive 12 to this negative 12, so I've got to add a 12 to both sides, that'll counteract the minus 12 or the negative 12. So I'm treating this like an equation. I want to get f all alone. And then we can read our answer and we can graph it and see what that looks like. So these cancel. Minus 12 plus 12 cancels. F is all alone. Awesome. Bring down your sign, the symbol. So bring down this greater than or equal to symbol. And then we've got 5 plus 12, 17. So there's our answer. Our solution is f is greater than or equal to 17. Here's how we say that. It's a mouthful to say, but that's it. F is greater than or equal to 17. So now to graph it. So make a number line, and please do follow along with me on this and try to just get some practice graphing your answers. I didn't include like a pre-made one because I want to show you how I do it and how it's totally okay to do it. Just eyeball these things. Doesn't have to be perfect is what I mean to say. So our focus is 17. So I'm just going to draw a line right in the middle and call that 17. Now let's put some numbers that are greater on the right and lower on the left. So I'm going to just space these out about this far. I did 3 more dashes on the right, 3 dashes on the left. Now, one thing we have to remember is our number lines always are smaller on the left and increasing as we continue from left to right. So what's bigger? Well, let's do 18 and 19 and 20. What's lower? 16, 15, and 14. So we're all set up now. Now we can actually show this graph. So I want to circle 17. This is a greater than or equal to. So because of that or equal to, we're going to fill in our circle. We're including 17 in the solution here. And it's greater than, so I want to shade and include those numbers that are bigger, like 18, 19, 20. There we go. It's not perfect, right? It's not amazing, but it's showing the information. It's showing that we're including 17 and we're shading things above 17. So it's a visual representation of our math statement answer. These are really both our solutions. And in Admentum, for our mastery test today and our big test later, you will see they want us to sometimes shade our answer like I did below, and sometimes we're just writing the math statement. F is greater than or equal to 17. So I want you to be prepared for both, for each question. Takeaways here, solve the inequality the same way we solve an equation. Identify what's happening to the variable, do the opposite to both sides, and then we need to be able to shade it and show like a visual number line answer as well. I'm going to wait like 10 seconds in case people are still copying, and we'll do example 2. Okay, here's example 2. G plus 4 is less than 15. Less than. Notice how I get to when I'm reading this, I see the pointy side first. It's first because that's what we get to first, right? Pointy side. So that means less than. So that's how we know how to say that. G plus 4 is less than 15. Okay, can anyone help me with my first step here? How can I start to solve this? Please. How do I start to get G all alone? Isolate the G.
Maybe like subtracting 4 from both sides, like 4 from 4?
Absolutely. Yeah, we're going to subtract 4 from both sides. Can I ask you why we're doing subtract 4 and not something else 4?
Because we have to do the opposite of addition.
Awesome. Thank you. So G is less than, let's say we did our minus 4 and our minus 4. I'm just going to write it on the top to kind of see where those go. On the left side, negative 4, positive 4 are gone. That's why we did that. And then on the right, 15 crashed into a negative 4. That's like saying 15 minus 4, 11. So G is less than 11. Beautiful. So there's our answer. Let's do a quick sketch of a number line. Just draw a line, put arrows on both sides. Let's put 11 right in the middle. Put some numbers lower on the left and higher on the right. Another thing I want to mention is try to make your different numbers and tick marks like the same distance from each other. Now notice mine's not perfect. I can see that mine's not perfectly spaced out. But at a glance, it does get the point across. You can, I think you can tell, like, okay, cool. So I see 8, 9, 10, 11, 12, 13, 14. They're all roughly the same distance away from each other, even though it's not perfect. Then you circle your number in question. And this time I want to shade less than, because it's G less than 11. So kind of make a big bar there going lower. Don't forget to fill in that arrow and make sure it's clear, like, hey, this is going downward, shading downward forever. This time I don't fill in my circle because it's strictly G less than 11. Excuse me. We only fill in the circle and color it in, shade it in when we have the little equality bar in our symbol. So we're done. All right, let's do another one. Okay, sometimes we'll have to multiply or divide to solve an inequality. Of course, right? Just like an equation, they're not just adding and subtracting. So here we have 1/4 x is less than 10. I'm going to write that out, how we say it. 1/4 of x, or 1/4 x, is less than 10. Okay, so we've talked about fractions in our equations before. It's kind of twisting my rule a little bit about how we do the opposites. Technically, that we're multiplying this 1/4 to x, right? So technically, we should divide both sides by 1/4. But dividing by fractions, I think, is adding in some extra steps. There's another way to see this, and it's not really twisting any rules or breaking any rules, but it is looking at it in a different way. So maybe we should look at this as not 1/4 times x, but what if we multiplied these together? That would be x times 1, which is x, over 4. So here's our problem, just kind of rewritten a different way. Okay, these are equal, so we're allowed to do this. All we did was multiply the 1/4 and the x together. Now, this looks a little different. It's easier to see what to do. This is x being divided by 4, so let's multiply both sides by 4. 4 over 4 is a 1, gone. So we have x less than 10 times 4, x less than 40. And again, we're going to make a quick number line. So I'm going to make my line, put 40 right in the middle. That's our focus. Put some numbers above and below. Try to make those tick marks equal, space away, but it's okay if it's not perfect. And then label them. And then you're going to circle your number of question. Now double check your symbols and stuff. This is x less than 40, not less than or equal to. So I'm going to leave my circle open. I'm not shading it. And again, like last example, we're going to shade lower because it's less than. So we may not always be shading the inside of the circle, but we always will shade like above or below our circle for an inequality. Okay. I want to look at example 4 because there's one more really important thing I need you all to see with me today. And after that, I think I might want to stop, even though I've got more examples to show you. Stop and have you start your mastery test with me now. Actually, I'm going to skip up to here. We'll call this example 4. Example 4. Let's cross that out. Example 4. Negative 5x is less than or equal to 30. Okay, this looks straightforward enough. What's happening to x? Do the opposite of that to both sides. So we need to divide both sides by negative 5. Fair enough. X. And then 30 over negative 5. Now remember, a positive divided by a negative is negative. 30 over 5 is 6. Now here's a trick though. This is very important. If we must multiply or divide by a negative, we must flip the sign, meaning change the direction. So here I had to divide both sides by a negative number. Then I'm going to reverse my symbol. Think of it as kind of like paying for multiplying or dividing by a negative in an inequality. If we have to multiply or divide by a negative, then we must flip the sign. So my answer here, x greater than or equal to negative 6. Let me shade that real quick. So I'm going to put negative 6 in the middle. This can be a little tricky because we're in the negative area of our number line. But the same rule applies, so I should have lower numbers. So negative 7, negative 8, those are getting farther down the number line. Those are on the left. And then higher numbers like negative 5, negative 4, negative 3 to the right. Hey, Beniam, you have a question? Okay, it's okay if you have a question. Please do jump in and ask. Might have just been a mistake. It's all good. But if you have a question, I want to hear it. It's all good. So anyways, we're shading at negative 6. My symbol now says x greater than or equal. So I'm going to shade above because I want to include the bigger numbers. Now, we haven't done this yet, but we can check our work like in an inequality the same way we do it in an equation. So here's what I mean by check the work. Let's do a test number. Let's do this. I'm going to write this. Check work. Check your answer. So let's pick a number to be x, anything that would be shaded. So I could do negative 5, negative 4, negative 3. But what about numbers that are even greater than those, like 0? Let's say x is equal to 0. This will be a good one to check. So I'm going to check x is equal to 0 in my original problem. So originally we had negative 5x less than or equal to 30. So if I plug in a 0 for x, I should get a true statement if my solution was correct. If x is like part of the solution, or I'm sorry, if 0 is part of the solution. So if I plug in 0 here, we have negative 5 times 0 less than or equal to 30. 0 times negative 5 is 0. 0 less than or equal to 30. Is this true? Yeah, this is true. 0 is smaller than 30. So that means 0 was part of the solution. So that means we did shade the right side. Now, there's a reason why we have to flip the sign, and it's because Actually, you know what? Let's try this. I have a video here, but I'm not sure if the audio is going to work. I hope it does. Let's try this. I'm going to play this short video. It's only like 2 minutes long. I just like how they explain it in this video. And rather than trying to copy them, we'll just show you this. Can someone let me know if you can or can't hear any audio, though, when we start it?
All right, so we want to investigate when we can flip the inequality. So let's first start with the number line.
Are you guys hearing any audio, the girl talking?
I don't hear.
No? Darn it. Okay. Sorry about that. I need to figure out how to share video with audio on Zoom. So we'll skip this. Well, actually, you know what? Here, I'll do this. Maybe I'll use this after all. So this girl is showing a really good example of why we have to flip the sign when we multiply or divide by negative. So let me see if I can do it justice here. So she's starting with -6 compared to 2. -6 is smaller than 2, so she's got her pink circle less than purple. So now she says, let's add 2 to both of these. So it's kind of like -6 plus 2 and 2 plus 2. So it's like adding 2 to both sides of our inequality. Let's see if she writes that. Okay. Sorry, she didn't write it out. But that's like saying plus 2 on the left, plus 2 on the right, which is okay. It's the addition property of equality. And that shifts my pink up and my purple up. But it's still the same inequality relationship. Pink is still less than purple. Okay, so from this point, let's say, what if we subtract the same thing from both sides? So -4 minus 5 should bring the pink circle down to -9. And my purple should go down to -1. So she's minusing 5 from both sides. So there's the shift. It just shifted everything down 5. No big deal. The inequality is still true. Pink less than purple. So now starting from here, she's got -4 less than 1. And if we multiply by something, let's multiply by +2, both sides. So that's going to give us -8, because -4 times 2. And then it should be 2 for purple. There we go. And notice that the inequality is still true. Pink less than purple. So this whole time, pink's been less than purple. They haven't like crossed over each other. But when we multiply by a negative, here we go. So starting from where they are, multiply by -2. Well, we know that negative times a negative becomes positive. And negative times a positive is negative. So what's going to happen is our purple and pink will switch places. There we go. Uh-oh, purple is less than pink. So that made our inequality not true. So what's happening is when we are multiplying both sides of our inequality by a negative or dividing both sides by a negative, we need to change the sign to kind of correct and adjust for that for those rules, for like negative times a negative makes a positive. When we do that, here, let me get this video out of here. When we do that, we're essentially like flipping our whole number line. And so we have to change our sign to account for that. So that might not be a great explanation, but that's why we are flipping the sign when we multiply or divide by a negative. So let me do one more with you quick. Here we have -1/3 x greater than 8. So notice that we have a negative in our problem. Uh-oh. We might end up having to flip our sign here. So if we rewrite this as -x/3, what I'm doing is multiplying my fraction to my x. Now it's a little easier to see. I want to multiply both sides by 3 to clear out that fraction. And I want to multiply both sides by -3, really, because this is negative x. So if we multiply -3, -3, both sides, then we get x, and we get -24. And because I multiplied using a negative number, I've got to flip my sign. So my answer is x less than -24. Now, we're going to see two-step problems like these. This is nothing really different than what we saw on Thursday and on Monday, except now we're dealing with the inequality sign. Not an equal sign. So we're going to solve it the same way we've been doing our other equations. So I've got 1/2 x minus 5 less than 13. I'm going to just rewrite my 1/2 x right now as x over 2. Okay, I'm multiplying my 1 times the x. And that helps me see a little better what my steps should be. So let's clear out that minus 5 by adding 5. Bring down the sign. -5 plus 5 is 0, so it's gone. And this will turn into an 18. 13 plus 5. Now I see, okay, I've got divided by 2, so I'm going to multiply both sides by 2. And x is less than 36. So really, we're not dealing with any crazy new math except for the inequality symbols. And then I do want you to feel ready and comfortable to hopefully not only solve it like I did here, but then graph it. And when I say graph it, I mean on a number line, just like these. So 36, 35, 34, and then do some biggers. 38. There we go. Okay. Well, I went too long, like normal. Any questions? Does anyone want to go over any of those examples again or have any questions, please? No. Let me do this. Let me see your notes. So show me your notes. I'm going to check you off for taking notes and participating today. And then we've got 10 minutes. The homework is to do the last mastery test in Unit 1. So that means it's called Inequalities, Solving Linear Inequalities. Okay, Lauren, I see that. Thank you. And Maria, thank you so much. Savannah, thank you. Savannah, where are you? There you are. Awesome. Levi, appreciate that. All right, anyone else? Joseph. Awesome, sir. Thank you, Joseph. Oh, Tiara, thank you. Tiara and Anaya, I see both of yours. Tiara and Anaya. All right, keep them coming. Anyone else have notes to share? Does anyone have notes and they are having trouble with their camera that you can send me a picture of them later? If not, then unfortunately I have to assume you haven't been taking notes. So please communicate with me if that's not true. And you do have notes, but you just can't share them for some reason. Anthony T, thank you. You can email them to me, just the picture. You can text it to me on Remind if you added me on Remind. Alyssa, I see you. Thank you for that, Alyssa. So Anthony, I'll be looking forward to seeing yours later. Please send me those. No big deal. Just send me a picture. And if there's anyone else who needs to send me a picture later, that's okay. If you need to look at the video later and then send a picture, that's cool too. I would appreciate if you do it the first time, like now, like the other folks, but later is better than never, right? So I'll have the video up later this afternoon at like 1:30. You can watch the video, you can take notes on the examples, and you can send me a picture and still get credit for participating. And since we're pretty short on time, I'm going to go ahead and say you're released for the day. However, you do have homework. The homework is to do the last mastery test. Tomorrow, we're going to do another activity together and some housekeeping. And then we're going to do a review of everything on Thursday. And then Monday morning, we're going to do our test.
I have a question.
Please go ahead, Tara.
So for the homework tonight, we're gonna do solving linear equalities.
Yes, inequalities, yes.
Oh, okay.
It should be the final mastery test. I don't have it open in front of me. Is that, let me know if I'm wrong on that, please.
Yeah, I after that I have the extra practice expressions and then the integrated math and then the other one, which is integrated 1A unit post test.
Totally, yeah. We're going to do the activity tomorrow. It should be called unit activity. And then we'll do that tomorrow, and we'll do our test together on Monday. On Thursday, I want to do a fuller review of all the different kinds of problems you'll see on your test.
Okay, cool.
Awesome. So basically for your class, everybody, we should have all your mastery tests done. If you're needing help on them, come work with me. Tell me. We've got our math tutor, Brandon, available for extra time as well. He is working Friday mornings. I think he's blocked off 2 full hours from 10 to 12 just for you guys to get extra help on your classwork. And then also you could probably work with him on other days if you message him, privately and get an appointment. Today at 3 o'clock rather, I'll be on this link again to give you extra help on any of the assignments or any questions. So if you are needing help on any of this stuff, please come join me at 3 o'clock today and we'll hopefully answer your questions and knock out a bunch of work together. Other than that, I'm going to go ahead and say you're released for the day. If you want to start your test now and get help in the next 8 minutes, that's all good. Otherwise, you're free to go. So thank you all for coming. I hope it was useful. Bye, Savannah. Bye, Levi. Thank you. I hope it was useful for you, and I hope to see you later at 3 o'clock if you need any help.
Bye, Josiah.
Bye, Tira. You take care.
You too.